Next up for this material is how to balance chemical equations. So as we've looked at, the law of conservation of mass tells us that the amount of material I start within a reaction, I need to have the same amount of material at the end of the reaction. I cannot create or destroy material. So the number of atoms I have on the left side of the reaction with the reactants, I need to have the same number of atoms on the right side of the reaction in the products. And when that's the case, then the reaction is said to be balanced. So here's an example of a reaction, a chemical reaction that we may have used over the weekend if you grilled out in your back deck. The combustion of propane in the presence of oxygen to produce carbon dioxide and water. However, there is one problem with this reaction as written. It violates the law of conservation of mass. If we look at the reaction, I have 3 carbons with the reactants. I only have 1 carbon in the products. And we'll also take a look and see that my oxygens and hydrogens are not balanced either. So this is not a balanced equation. So how do we go about balancing a chemical equation? So if we take a look, I'm going to start with the propane. The propane is going to react with oxygen to produce carbon dioxide and water. So the first thing we want to do is take an account of how many of each of the atoms we have. And so I like to put this in a table. So atom, I've got carbon, I've got hydrogen, and I've got oxygen. Then I want to look for my reactants and my products. And so if I look at the left side of the reaction, I have 3 carbons. So with my products, I also need 3 carbons. So how do I get 3 carbons? Well, I already have 1 in carbon dioxide. I must need to use the coefficient of 3 in front of that carbon dioxide to give me 3 carbons. So 1 times 3, that'll give me 3 carbons with my products. The next I want to take a look at is hydrogen. So in that propane, I have 3, I have 5, I have 8. I have 8 hydrogens represented with my reactants. With my product, if I look at water, I only have 2 hydrogens present. Well, I now multiply that by 4 to give me a total of 8 hydrogens in my products, so that it equals the number of hydrogens in my reactants. So now I've got my carbon dioxide balanced and my water balanced. I put the coefficient of 4 there. The next thing I want to do is take into account how many oxygens I have. So if I look, the coefficient of 3 with the carbon dioxide with 2 oxygens each, 3 times 2, I've got 6 oxygen there. And I have 4 times 1, I have 4 oxygen there. So 4 plus 6, I have a total of 10 oxygen. Well, I already have the subscript 2, so I only need a coefficient of 5 because 5 times 2 will give me 10 oxygen in the reactants and 10 oxygen for my products. So now I've balanced the equation with respect to the reactants and the products. I have 3 carbons for reactants and products, 8 hydrogens on both sides, and 10 oxygens on the both sides. So your best approach to balancing chemical equations is to take a step-by-step approach and changing 1 coefficient at a time and balancing that reaction with respect to 1 of those atoms at a time. We don't want to change multiple things at once because that's going to change multiple counts of the elements present. So here are some sample reactions for you guys to try balancing. We've got oxygen with phosphorus trichloride. So if we look for this reaction, on the left, I have 2 oxygens. On the right, I have 1 oxygen. So I must multiply that by 2. That would give me 2 phosphorus. So that must mean I need 2 phosphorus here. And check my chlorine. 2 times 3 is 6. 2 times 3 is 6. My chlorine is balanced as well. So with a coefficient of 1 out front of the oxygen, 2 phosphorus trichlorides are going to produce 2 phosphorus oxytrichlorides. For the next reaction, phosphorus reacting with nitrous oxide, also known as laughing gas. to produce P4O6 and nitrogen. So to balance that reaction, I already have 4 phosphorus, I have 4 phosphorus. I have 2 nitrogen, I have 2 nitrogen. What is not balanced, however, is the oxygen. I need to have 6 oxygen, I only have 1 oxygen here. So the coefficient of 6 out front of the nitrous oxide gives me a total of 6 oxygen. Now oxygen's balanced, nitrogen is not. Now I need to include the coefficient of 6 in front of that nitrogen as well. And now all the elements are balanced in this reaction. In the next example, I've got calcium phosphate reacting with phosphoric acid to produce calcium dihydrogen phosphate. So for this one, there's quite a few different elements we need to take a look at, but I would start on the left and I would start with calcium. I have 3 calciums in calcium phosphate. I only have 1 calcium here. So to put a coefficient of 3 out in front, now my calcium is balanced. Now let's take a look what that does to everything else. And it might be easier to break down the calcium dihydrogen phosphate to see exactly. I have 3 calcium dihydrogen phosphates where each molecule has 2 of these. So I really have 6 times H2PO4. So what that means is I've got 6 times 2, I have 12 hydrogens. So to have 12 hydrogens on the left, I'd have to put 4 out front of here. 4 times 3 would give me 12. Now let's see what that does with everything else. Well, I've got 2 times phosphorus and 4 times phosphorus. So I've got 6 phosphorus. Let's take a look over here. 6 phosphorus. Phosphorus checks. The next I'm going to look at is oxygen. I've got 2 times 4, that's 8. And then I have 4 times 4, which is 16. So 16 plus 8, I've got 24 oxygen. Now if I look over here, 6 times 4 is 24. My oxygen is balanced as well. So even though this looked like a really complicated example, it wasn't too bad once we got started and we approached it in a step-by-step manner. In the last one, we've got arsenic trisulfide reacting with oxygen to produce arsenic trioxide and sulfur dioxide. This one is a little bit of a challenge, and we're going to learn a little shortcut that we can use as well. So if we take a look, I've got 2 arsenic, 2 arsenic. That's balanced. I've got 3 sulfur, I've got 1 sulfur. So a quick way is maybe I'll say I'll have a 3 in front of the sulfur. Now sulfur's balanced, arsenic's balanced. The next thing I want to do is take a look at how many oxygens I have. I have 3 oxygens here, and 3 times 2, 6 oxygens. So 6 plus 3, I have 9 oxygens. Well, I have the subscript of 2 here. So in order to get 9 oxygens on the left, I would need to say, well, I can't put 9 out in front, but I can put 4.5, because 4.5 times 2 gives me 9 oxygens. There's only one problem with that though. You need to use whole numbers when you're balancing a chemical equation. So I cannot use 4.5. But what could I do to make all the coefficients in this last reaction a whole number? Well, I can multiply the whole reaction by 2, multiplying every single coefficient by 2, and multiplying 4.5 by 2 will give me a whole number. So multiplying the whole reaction by 2 will give me 2 arsenics trisulfides, 9 oxygens, and that'll produce 2 arsenic trioxide and 6 sulfur dioxides. So we can't get away with using a half number like 4.5, but we can use it as a stepping stone to get to the final answer. We can see that 4.5, I multiply that by 2, that will give me a whole number. So multiplying the entire reaction by 2 will give me a whole number coefficient for every reagent and product in this reaction.